Hello, geometry students. I hope you are doing great. We are continuing on in chapter 11. We've done 11.0 and 11.1. Today we're going to do 11.2, a little bit more about circles. In our last lesson, we talked about the arc measures and arc length. Now we're going to talk about the circle area and sector of a circle area. So if you want to put 11.2 at the top of your notes, we'll just put the two formulas right here. The first formula is to find the area of a circle, and that is just going to be pi r squared, where obviously r is the radius of the circle. So let's do an example here. Example number 1. If we have our circle, and the diameter is marked as 20, we want to make sure to notice that the radius would be half that amount, or 10. And then to find the area, we would take pi times 10 squared, which would be 100 pi. Normally, we just go ahead and leave our answer like that, but if you needed to round it, that would be approximately 314.2. And let's say that this was in meters. This would be meters squared. Okay, so that would be an example of using area of a circle. Now, there is another formula. This is just regular area of a circle, and this is area of a sector. So area of a sector. So when we're talking about area of a sector, we mean basically a slice. So let's say, for example, a slice of pizza, a slice of cake, but not the whole pie, just one slice. So we're just talking about a portion of the area. This formula is kind of similar to the one we used to find a portion of the circumference. What we want to do here is say that the area is x over 360 times pi r squared, where x is my central angle. So for example, let's say that this is 45 degrees here and the radius is 3. If I wanted to find the area of that little slice, I would write 45 over 360 times pi times 3 squared. Now, 45 goes into 360 8 times. So I can take 45 divided by 45 and get 1, 360 divided by 45 and get 8. 3 squared is 9, so this is 9 pi over 8. If we want, we can turn that into a decimal. We could have done that up here if we wanted. Just take 45 times pi times 9 and divide by 360. Or if we want to just take 9 times pi and divide by 8, either way, we should get 3.53 feet squared. On your SAT exam, they're going to leave the exact answer. Okay, let's do, let's see, that was example number 2. So example number 2, let's do example number 3. Now this is a little bit of a trick question. So let me set this up for you. We've got a circle. This angle here is 20 degrees. Our radius is 7. And the question would typically say something like, find the area of the shaded region. Now, most students, when looking at this, myself included, when I first look at it, I see the 20 degrees. But notice the shaded region is not the part marked with the 20. That would actually be 340 degrees, right? Because there's 360 all the way around, and if you subtract 20, there's 340 left. So the area of this shaded region would be 340 over 360 times pi times 7 squared. Now, since there's a 0 on the end of both of these numbers, I can divide top and bottom by 10 and cancel those out. Also notice that 2 goes into both of those numbers. So 34 divided by 2 is 17. 36 divided by 2 is 18. So now I've got 17 over 18 times pi times 49. If I multiply 17 times 49, I get 833. So the exact answer to this would be 833 over 18 pi meters squared, if we were talking in meters. Or if I multiplied that out to turn it into a decimal, it would be 145.4. So those are pretty traditional problems where you're either trying to find the area of the circle or you're trying to find the area of the sector. Now we're going to do two problems that are just a little bit more complicated. So two more examples. With example 4, I have a figure here that's got more than one shape to it. So we need to notice this dot here. And then this is a length of 6 and 9. And this is 5. Who can tell me what this length is here? If the entire base on the bottom here is 9 and the top one is 6, what would this little piece represent right here? 9 minus 6, which would be 3. Then you want to notice that there's a right angle here, and this is a 3, 4, 5 triangle. Now you could have done Pythag if you wanted to, but let's put into words what's going on here. First, I'm going to do some shading. So a problem like this would typically say something like, find the area of the shaded region, and everything but half of the circle would be shaded in. So if we put that into words, notice that my bigger shape is a trapezoid. So I want to take the area of the trapezoid, and then I want to subtract off half of the area of a circle. Now, we reviewed the formula for area of a trapezoid in our last lesson, I believe, or maybe that was 2 lessons ago. I think it might have been 2 lessons ago. It's 1/2 the height times the sum of the bases. And then for half of the area of the circle, I would subtract 1/2 of pi r squared. Let's plug in what we know now. The height of the trapezoid is 4. The 2 bases are 6 and 9. And on the circle, the radius is going to be what? What is the radius of that circle? If the height here is 4, the radius is going to be 2. Half of 4 is 2, so I have 2 times 15 minus 1/2 pi times 4, or 30 minus 2 pi, because half of 4 is 2. So the exact answer would be 30 minus 2 pi. If we want, we can turn that into a decimal, and it would be 23.7. But usually in that kind of a situation, you would just leave it with the pi in it. Okay, last example, example number 5, we're being asked to work backwards. It says, find the radius of a circle with an area of 63.62 square yards. So my area is pi r squared, and I'm being told that that area is 63.62. So the way that we can handle this is using opposite operations. The opposite of multiplying by pi is dividing by pi. So we divide both sides by pi. These would cancel out, and I would have r squared is approximately, if I write this out really far, 20.25087. If I take the square root of both sides, I get about 4.5. So we're kind of working backwards on that one. Okay, that's all I've got for 11.2. Thanks so much, you guys. Bye.